Good morning. I would like to continue with where I left off regarding making an enclosure for an electronic equipment. So, at two levels, at the initial level it is only a prototype enclosure by which you pack all your whatever electronics, your circuits with the functionality in mind and to make sure it works well. If you remember in the previous presentation I told you a minimum of probably 3 iterations are required even for a good workable prototype. It is not a lab demonstration, it is not a lab exercise, it is not a simple one off what you call one off type of an equipment you need to show to the intended user. This one from now on it is expected you will have a nearly perfect object like this. You have seen this, no? I think all of us are familiar with this. This is once upon a time hard disk, and right now with the new technology it is possible for you to make a few numbers of these in small quantities and then now put it for a beta test and eventually go for the ultimate final production. But then the way these things are made, even for you to do the initial testing you probably need something which is very professionally packaged, so that it will not be susceptible to normal routine handling, routine vibration and all that. So, bear with me, the little bit of you may find a little bit of a repetition, and the core or the focus of the whole thing is you figure it out yourself. Unlike high level abstraction in mathematical correlations or relationships, you cannot represent anything by a simple variable and then you play on the variables and then in the end you try to have an optimum design right away, because things are changing all the time. So, even this is the same thing it is with materials. Right now this is current to the extent that in case you are in a small thing like a lab or you have access to a vendor, you will be able to make use of things. One of the first thing about this is, kindly if you can read along with me, depending on the main function the material is chosen. Looks obvious, is it not? It is common sense, but sometimes we forget, or rather I am sorry we can get carried away by looking at a piece of equipment which is already in production and try to see whether we can make a thing like that. At one extreme we end up with having a very cheap plastic box. My own thing is saying fit everything into a bread box, or the other extreme take another unit and try to modify it. Somewhere in between we have an inexpensive unit like an AC DC adapter uses a kit, it is made of ABS plastic. Inside there may be small parts like a phenolic printed circuit board, PVC clad copper wires, rubber grommets, brass contact pins and steel fasteners. A large unit like a VCR, right now VCRs are obsolete, but then you have probably a Blu-ray player or now 2K and 4K players may have a big die cast chassis, a molded front panel, acrylic windows and mild steel sheet metal covers. Sheet metal covers are, because it is flat, by definition even now anything flat and wide and which has to occupy a very small space, you can't beat metal. And it is commonplace to call a sheet metal of any steel. So, by default if somebody is referring to sheet metal it probably means steel, otherwise any metal in a sheet form, example aluminum, or you can have brass sheet and all that, no, generically they come under that. Then we have this acrylic windows. Acrylic has an advantage, the mu or the optical index is very close to air and little close to water, by which it will continue to be transparent, and the properties can be modified such that if you want you can have a higher index, or otherwise you can have a lower index and so on. First priority is it clear, nothing to worry about, it is as clear as glass without the chance of breakage and easy moldability. So, any windows you see, any small thing, and including a thing called a light pipe is probably made out of a acrylic molding. But then acrylic is not yet scratch proof. So, they use ABS and various other things to see them better. If you take a portable stereo player, may include a load bearing chassis. In this case a stereo player, this particular thing referred to an old cassette player. So, obviously the chassis could be made out of mild steel sheet, covers made of ABS. You see here slowly we are coming into a very interesting thing. The advantage of this new molded or injection molded parts, plastic can easily be plated, and in fact if you look around your house, all the taps or faucets which have a fancy shape are all probably made of plastic. One giveaway is that there will be a sticker on it saying do not use any material which is likely to scrub, use a non-scouring pad and then use mild soap and all that, because the thickness of the coating is very small, of the order of a couple of microns, and it does not stick very well to the base. The first fault, it will come away. So, most of the things you see around which look a little bit metallic are probably all made with ABS, which is plated with nickel. That is a process itself. So, we have ABS with nickel, transparent parts made out of acrylic, internal electromechanical items like levers, pulleys and gears made of nylon polycarbonate, and various acetal copolymers. These acetal copolymers are slightly difficult to mold, but still they are the strongest. So, you have very small gears with the modules of the order of even 0.3, 0.2 mm, they are all made with these acetal polymers which will maintain the shape without any problem. Things which do not have much torque probably continue to get made with other plastics, but the ones that need to have good transmissibility of force have all this plastic. Handheld devices like cell phones, calculators, cordless handsets and the like will have most parts made entirely out of various modified versions of ABS and PS, polystyrene. So, it is cheap. Polystyrene is what your soap cases are made of, and depending on the cost. But if you are into cosmetics, let us say you want a compact powder or you want that multicolor rouge box, they use even expensive this thing, because the feel is very important, it should look valuable. So, you do not go and buy really valuable any item which is not packed properly and not packaged outside properly, because the packaging is part of the use, and this thing when you receive a gift you expect it to be gift wrapped. So, we have this problem of, due to the compact nature of the packaging involving environmental, including sealing and shock resistance and form requirements, very quick assembly, very high volume runs and relatively less demands on strength aspects, all parts are made by injection molding. Inside items, total part and component count is critical, and all attempts are made to minimize the part count. All loose fasteners are eliminated in favor of snap fits. Fasteners no, snap fits yes. Functions of parts are combined and value analysis is used very vigorously, intensely, otherwise you cannot meet the target cost. Product cost has to be kept low. So, the only way of making a product cost low is obviously to make things manufacturing cheaper. While a lot of attention has gone into making the electronics inexpensive, the same amount of this thing is slowly coming into manufacturing, so that the enclosure also is there. So, we go back here to check about large instruments like say inverter housings, oscilloscope and signal generator enclosures, power management hardware, converter and drives involve the use of heavy and rugged components like this IGBTs. IGBTs are power modules, insulated gate transistors, large heat sinks, blowers, heat dissipating, heavy transformers and bulky filtering capacitors, all this stuff. In applications for housing these items, only mild steel and special alloys of aluminum, silicon, magnesium are used. Even here cost considerations often result in the use of only variants of mild steel. So, as of today, if you now go and inspect your system unit of the computer you have, the main housing is invariably made of mild steel sheet. Lot of expensive operations are done, but overall the cost of modification of the raw material into this is the lowest. So, they continue to use this mild steel in the large this thing. Here that is what initially in the lecture I was talking to, there may be a little going backwards and forwards. So, some of these may be repeated in the later slides, but it is for you, so that in case you are watching it on the video, maybe you should go back and check and just see whether these things make sense. Still no, the issue of mild steel is still there. You also have plastic hinges. If you have a specs case of where you keep your the spectacles, it has what is called a living hinge. Often we open it and the corner, if you see, it is made out of a what is called a living hinge. The whole thing is molded like this. After that it snapped in place and then it just stays like that, and then a few hundred operations, nothing happens with this. However, if you come to the specs themselves, okay, or I can see here if you can make it. Next time you go and examine these things. You see here there is a beautiful, this frame is probably molded plastic with a small spine made out of steel, and then you have a hinge. As of now, nobody has been able to replace the hinge automatically with a plastic, not yet been replaced. Okay. And then inside this, as if it were not sufficient to make it more usable, they have even put a small spring and all and made a very elaborate arrangement, and then you also have a bridge support here. So, the previous slide I started with saying we will talk about little bit about the industrial racks and so on. Next round when I make my presentation, I will probably take you on a small video this thing which shows that large racks which we have, which are used for communication equipment. Loosely it is actually, it follows that IEC 529, loosely we use the word saying rack. Rack refers to that vertical standing structure. Those racks were earlier made almost exclusively of steel, but now since the progression of aluminum extrusion techniques have become easy, and then the perforation for mounting and all is easy, a lot of them are made with special aluminum extrusions. These aluminum extrusions have special cross section by which using other hardware you can make things wider, taller, can increase the depth, and then also you can accommodate other structures within them. Now again, this is where I was telling you, I have to, I need to jump backwards and forwards, otherwise it will just end up with like usual examination material. You by heart a list, reproduce it, you pass the exam without understanding too much about what is written in the list. come back to the thing, various electronics enclosures are made of different materials to suit functional requirements. Obvious, the choice of material depends upon requirements like stress, feel, appearance. You have seen this, no? These are all very important. At the back, what you do not see is probably manufacturability, availability, and price. What is obvious is that, in case the material cannot take the load, it has a tendency to buckle. It may not fail, but it will tendency to buckle. That will spoil the feeling of your whatever it is. Imagine you are going on a bridge, and then another heavy truck or something passes by, you can feel the vibrations. It is not dangerous. In fact, if they were to make a bridge very brittle, chances are it will crack easier. So, it is flexible. This whole studio also, no, we try to isolate it as much as possible, so that vibrations are not transmitted automatically. This is where we have the thing about how to make a material which feels good. Material has to feel good. Next slide talks about small modem, a typical example of a professional product. Enclosure is probably made of ABS. At one time, the so called professional products or black boxes were not visible to the public. They all nicely stayed away in some place. But as things progress now, even on your table, you are likely to find 1 or 2 modems, and it can't be a unsightly black box. An unsightly black box of a modem does not give the same confidence as something which you would like to make it more presentable. So, these days, though it is typically a professional product, the enclosure is made of ABS, a common plastic. Most of the parts would be made of either ABS, polystyrene, polypropylene and polyethylene, because all of them can be molded easily, and then you can make them in millions. And then only one part of it, probably the top enclosure needs to be redone, and then we are in a generic group of products where these things can be used. So, if you go to any of the online retailers and just look around, go to any of the online retailers, the first thing that comes to us probably is Amazon. We have dozens of them. Ask for a modem. You will be surprised to see how many, how much of effort has gone into make them look good. It is not your powder compacts, or it is not your grooming products that have all the things. Even semi-professional products are meant for a user experience, the external appearance, and something very, very important is, from the marketing point of view, we need a differentiated product. So, we have market segments. So, in a professional segment, they probably do not work too much on the external appearance, color and all that, but they are ready to pay a premium for something which will have a guaranteed life, saying next 10 years I need not touch it, will not go obsolete on its own, we can upgrade it. But if the similar function product is kept in let us say directly in a visible area, while that is also an important thing which even if occasionally it does not work well, appearance seems to be critical. And other thing is, can it hold your coffee? It is real. Spillage, accidental droppage, all these are very real for desktop equipment. Occasionally they spill over, but then nothing is lost. If you make it in a large quantity, you can replace it, not repairable but replaceable. Getting back to my slide, an expensive portable stereo will use compound assemblies of ABS, acrylic, polycarbonate and nylon for the external covers, and use special quality mild steel for the load bearing chassis. Spring steel would be used for all the flexible parts. So, if you are to look at a DSLR, the costliest DSLR still come with a magnesium body. Inside there is a magnesium shell. Probably the costliest camera, I won't know whether I should say Mamiya or Hasselblad, or I do not know what people use. For all the money you pay, you get a cuboid in which 5 of the sides have to be purchased separately. You buy the top, you buy the back, you buy the lens, and then you buy the bottom, probably a little bit of, and one of the sides, the winder mechanism and all that are separate. But the core skeleton inside is made out of a special magnesium alloy, which will make sure that it does not distort itself, and any of these accessories can be fitted onto that without any problem. That is a professional thing. It costs a lot of money. I do not know whether it costs $5,000 or something. It is still a lot of money, expense. So, we will get back to my slides. Parts having electrical functions like conductor, being a conductor, will use copper, brass, silver and gold. Gold is not the best conductor. If you go back to your physical tables and see, gold is not the best conductor. Actually, silver is the best. But the advantage with gold is that contact between 2 gold parts is stable. It will not change over time or with the minor corrosion and all that. In contrast, copper and brass have a tendency to corrode very quickly. Copper forms an oxide, brass also has, I do not know what all colors it has. And silver is better to the extent that it has lowest conductivity, and the oxide of silver is not bad. Something which gets oxidized is no problem at all. So, even the costliest thing like huge contactors which carry a lot of amps, but I will stick to maybe 100 amps. The actual contact button inside is probably made out of copper, but the part which makes a contact, the pressure contact, the last portion of it is a silver. The copper takes all the current to the last bit of the contact, and the last contact button is made of silver, and that also there is some special alloy. So, that guaranteed million operations or a couple of million operations, nothing will happen to that. Getting back here, insulators, while that is all about the conductors, insulators are made invariably of phenolic, epoxy, nylon and occasionally Teflon. Teflon flows. Teflon is not a stable strong material, it has a tendency to flow. So, things like phenolic, glass epoxy, nylon, and then these days there are unbelievable amount of plastics. You should go and check on the plastic. So, typically even your commercial switches, probably they have polyphenylene sulfide or some PPO, PPS, I do not know all the materials. All those materials are even used in your commercial modular switches. That is lot of money and thing has spent into it. And then the advantage is saying they are not disturbed by temperature, and in the very unlikely case of failure, they do not add to the hazard that can be done. So, these what you call sulfide and these PPO and PPS materials are chosen in a special function. So, these days if you are to build an equipment, especially if it is supposed to be reasonably rugged equipment, you are not expected to meddle with the UL listed parts, including the connectors, including the cables, and in case you have a power switch, because all approved, and then it is made for a fire rating. So, now it has gone to ROHS, restriction of hazardous substances. The moment they are approved, it is much easier for you, otherwise you have to seek approval for everything. Second point is what is actually the core of my whole series of lectures, saying a design student must expose him/her self to various materials, by opening existing products, and checking with the suppliers what is used in their manufacture. Creative uses as used in the arts to attract attention are to be avoided. We know glass slipper fits only one person, it does not fit others. Only recently I had a chance to see one more variant of the Cinderella. I do not know, probably the what do you call, a stepmother takes and shatters the remaining glass slipper. So, understand, no? So, somebody can't pair it and say this is the same, the only other slipper is gone. So, still the prince comes back with it and fits and all that. The moral of the story is, first of all, it is easily crushable, you can shatter it. Secondly, it is made for a single function, for single use, it is almost like a thumbprint. So, it will fit only one person and then maybe they can even walk in it. It is available now, I should not use the word, no, but I will say we have the glass slippers available, and in fact there are some in which you can walk. I am talking about the people who would like to wear them. So, these are all generally, we also have a cardboard chair. You do not have many cardboard chairs around your house, is it not? You have normal polyethylene or even I do not know, modified I do not know what these chairs are made with, probably lot of them are made with ABS. You have plastic chairs, but cardboard chairs as yet continue to be a novelty. Then people have built houses, and then if you look at the equipment that is shipped and comes to us, often you will see we have load bearing recycled cardboard packaging that is used inside, except the very core things, all other places you have these beehive structures. You have these panels in which you have support structures where the cardboard is used a compound material, it is used on edge such that it supports the whole thing. Advantage there being, contrary to our normal expectation, something which gives or which takes the shock is more desirable than something which does not give. So, it is not correct if all the gaps you have, you fill it up with your PS foam. Such a thing is not very good, but if you see a carefully molded thermocol or polystyrene foam product, skin outside is there and the part which is held inside, in between it is covered with or connected by various ribs which will fail or which will buckle and take the shock. That seems to be a very important issue. Otherwise, if you bang something on the outside, it should not go and bang itself, go and bang the things inside. So, typically a honeycomb panel is a reasonable what you call a compromise. It is just strong enough and then it remains flat. So, you still have cardboard panels which are used, you can even build a house with it, and I do not think your cake boxes are made with anything but cardboard. It has lot of coatings and so on. Now, we get this other thing, no? Do we nearly need so much of chrome everywhere? Incidentally, that chrome bumpers and all what you see in old automobiles, they are not chrome as such. The core of it is still a mild steel, except that monstrous presses which will deform things into that shape, and then later on it is coated with copper because copper base plating is required. Then on top of it they put nickel. Everywhere nickel, only in some very occasional cases you have a chrome on top of it. Nickel is the one with the bluish and things look good, and if you see the chrome, it has a slightly non-bluish appearance, it has a more natural whitish appearance. So, so called chrome bumpers are actually not chrome bumpers, they are nickel with chrome on top of it. Do you need it everywhere? Some places it is expected. I have shown you that Vertiophone, no? I am sure there are some places they have actually used metal. It has a dual function. First of all, it is stronger, much stronger if you have a metal. Secondly, it is very easy to chrome plate those things. So, even in the case of our electronics it is used. You have seen this, no? Material selection should be based on practice and not novelty or shock value. It makes sense. Sometimes in some places more than shock, the new use of it is very what do you call, a novel use of an existing material. Still people take that, okay, there is an intelligent designer here, he has been able to use it, they are happy about such a thing. So, as I said, glass is good, no issue about it. You can maybe replace it with polycarbonate, you can replace it with anything, or you can go back to quartz. Quartz glass is glass, absolutely, or why not sapphire? This is just a listing, okay, not as a filler, but I expect that the student should be able to see what is going on here. Normal functional requirements are, it starts with strength to the load bearing capacity, usually indicated by the ultimate tensile and shear strength. Material which has an inherently better yield stress can obviously withstand more loads in a given thickness compared to another material. So, if you remember, yesterday I had shown you a power supply where I have opened the cover and showed you that they use a very thin material, absolutely. The whole thing is made mild steel. Something has been done by which it does not look good, but it looks professional. It is thin like 0.3 or 0.4 millimeters. Even if you take your car, of course, in the parts where I live, we have cars which are a little lower price. Probably the costliest car costs $20,000, not more than that. And the cars like what we have, I think all of you must be familiar with the $2,000 car, are they? 1 lakh nano. Nano refers to 10 to the power of something, no? And then it has been made into 10 to the power of 6 rupees, I am sorry, 10 to the 5 rupees instead of 10 to the power of I do not know how much minus something. All cars incidentally, if you see the doors and all that, they are thin, not very thick, very thin. And over the edges where the door opens, so imagine this is the panel, they fold it over, and then sometimes they do some special treatment to see that edge does not get spoilt. But however, if you employ a shortcut, next time if you take a car and if you happen to be living in the coastal places, open the door, look at the edge, preferably towards the bottom, you will see that corrosion has set in. Not easy to get rid of it because the process is such, and trapped water, trapped condensation, all this affects that thing. So, coming back, it can withstand obviously strength, a strong material can withstand loads in a given thickness. Tempering and hardness increase stiffness. Tempering can reduce elongation or deflection for a given load. Relatively stiff materials like steel or silicon magnesium alloys can lead to parts which can be made thinner. This will aid in making compact and tight packaging. It is needed because the amount of functions that these days we are expected to perform, more and more stuff is getting packed inside. There is no gap between any two parts. This will aid in making compact tight packaging. The equipment is always under the constant threat of shock. One of the primary requirements is the deformation should be small. The unlikely case that some shock comes, it should not get transmitted. The moment it gets transmitted, failure occurs. So, if something absorbs it by taking a bit of deflection, very much possible for you to accommodate the materials. So, next part after the strength obviously comes this corrosion resistance. Long term utility of the equipment is the next most important consideration. So, this corrosion resistance is very critical. A little while back I was referring to about the corrosion around car doors. Same thing, it happens everywhere. If you go and check the things like your old refrigerators at home, traditionally refrigerators are all made with mild steel and condensation is real. So, down things rust, we cannot help it. Same thing with in the case of electronic equipment also, corrosion is real. We think we are in a benign atmosphere by just putting a air conditioning in the place. The moment you try to chill something, humidity goes up, the amount of water present in that thing is same, but you have cooled down and the tendency for it will get more and more saturated and humidity will get increased. Moment humidity is increasing, condensation starts taking place. You may not see it, that is the only thing. Next time now you say what has happened to refrigerators, you do not find the condenser at the back anymore, and in fact sides of the refrigerator are expected to be heated hot. Not long ago, only about 30 years back, they said you should never have a hot surface, you should have a cold surface, otherwise you are beating the whole system. Think about it a little. Electronic circuit elements, I mean I am sorry I could not switch it on. So, the corrosion resistance helps in the long term utility. Electronic circuit elements interconnection mechanism like sockets, normal leads, substrates, joining process are not intended for operation in harsh external environment. It is the enclosure that has to ensure that corrosion will not lead to equipment failure. Seen that, no? We use common things. I think I showed you this wireless mic and the transmitter of it yesterday. So, it had the wireless mic has a connector here. You have seen this? There is a nerd something and you have to turn, and I will not do it now, and there is a small rubbery mute switch. I was getting ready. You have a spring steel clip, so that I can clip it here, I can clip it on my back or any convenient place. I can put it in a pocket or it can be in my trouser pocket. But you see here right now, in the thin form that is possible, you can't beat good old steel. I can't say what grade of steel, but it is steel. Now look back at your portable thing, maybe you have an MP3 player or anything, no? You may not find this sort of thing. Instead you have a tab, probably it has a spring inside and the tab closes and all that. It was very cheap. Like I have this small this thing, something else has been done to make it just clamp onto my lapel.